Okay, so I feel like we're winding down a bit, looking around at the number of people in class. You know, that's fair enough too. Obviously, one of the assignments is due in a few minutes, and then the other one is next week. Yeah. Oh, sorry, yeah, well, okay, a good few minutes. In 12. 12. No. Yeah, so. It's there anyway, it's your grand, so if it's already up, your grand, so. Anyway, so there's one due today, one due next week. I mean, obviously, if you've handed up everything, you're coming to class or not coming to class, after it's all handed up, you know, you can't possibly change the outcome of your result, you know, the module for you. And I mean, there's a very real extent as well to which the stuff we're going to cover is not going to have any impact on the outcome in terms of results. So I appreciate you coming. If you don't want to come, if you're going to be strategic about it and spend, you know, time on something that can change your marks, that's fine too. I'm not going to get upset or be insulted or anything. We all live in the real world. But anyway, I'll be here every class until the end of week 12, and I will endeavour each class to give you something interesting and relevant and useful. Okay? I'm going to talk about two things today, if I get time. First thing I want to talk about is character sets and internationalization. So it's tempting, if you're a native English speaker living in an English-speaking country, to sort of somehow imagine that everyone in the world speaks English. And of course they don't. Lots of people in the world speak English, and lots of people in the world live in countries where they speak another language and they also want to speak English. But if you are selling products or services to people for whom English isn't their native language, then you need to deal with them in their own language. And even in situations where people would be very competent in English, it's still considered a good idea to offer them websites in their own language. It suggests to them that you're interested in them. You're interested in them, having them as a customer. So, I mean, everyone in the Netherlands speaks English. Everyone in Denmark and Sweden speaks English pretty much, I think. But it's still worth your while having sites in Dutch and Swedish and Danish and whatnot. You'll even find that Spanish companies will have websites in Castellano, which we would know as Spanish, and Catalan, which is a language spoken in Catalonia. Now, everyone in Catalonia speaks Spanish, but companies will offer sites in Catalan also, in order to say to those people, you prefer Catalan, you know, we respect that, give us your money. So it's a business decision. And so you need to be able to provide for that. Now, what we're going to look at today is character sets. And if you get a bit of time, we will talk about internationalization more and more generally. These notes, by the way, these slides are from Maeve. I don't know if you know Maeve, but thanks to Maeve for doing all this work. So, sometimes you get a message or you go to a website and things are a bit garbled. You get a bit of gobbledygook. And that's usually as the result of the character encoding being off in some way. And the problem stems from the fact that ASCII, the main character coding system that we use, the American Standard Code for Information Interchange, is completely Anglo-centric. It's ironic it being the American Standard Code for Information Interchange, when of course they would have, many Spanish speakers. You could almost forgive the British standard code for information interchange, not including any foreign characters, but that the Americans would be ignorant of the Spanish speakers among them does seem a bit strange. No, it was some time ago. So ASCII's been around for a long time. So characters are letters of the alphabet or punctuation or symbols or whatever. Now, a character set then is a collection of letters. Now, I'm not talking here about the difference between, say, Helvetica and Times Roman. We're talking about, A, B, C, D, or alpha, beta, gamma, whatever it is the Greeks use, or whatever it is people use to write Hebrew, or in Japanese we a, I, u, e, o, kaki, ku, ke, ko, mami, mu, me, mo, whatever. So each character then within a character set is going to be represented by a number. So we have a big table with numbers and the characters. And what we're talking about now in this class is the mapping of numbers to characters. So if you get a message and it says, 01101100, what character is that? Well, the meaning of that bit sequence is going to depend on the character set that you're using. The bits themselves have no inherent meaning. They only derive their meaning from the table that you associate with them. And when you get gobbledygook like this, usually what's happened is that the sender and the receiver are not working off the same table. When I sent 01101100, I thought that meant whatever. But when it arrived at your place and you looked up what 01101100 meant to you, when you looked that up, it meant something else. And so we have some confusion. So that's what the term code point means. Now, look up here up the top, this I18N. It turns out that people that work in internationalization and localization, when they go to meetings, they get fed up of saying internationalization all the time. You can imagine it's a bitch to type as well. So you have this shorthand I18N, which I didn't know till I went to a meeting once and I was like, what's I18N? So they talk about I18N and they say it like that. They say, so the I18N for this project is going to cost whatever. Or I work in I18N. Or how long would the I18N for that take? So, yeah, you would think, but they do. They talk like this. So it's just good to know what that means. Now, good morning. So we have a universal character set or Unicode. Well, I think I prefer to look at ASCII. So, do I have an ASCII table there? So we're familiar with ASCII, which is a 7-bit code, and that doesn't really contain any foreign characters. Now, in order to solve this problem, then we came up with Unicode. And Unicode was a coding system, a character set that has many, many code points. And the idea behind Unicode was that we would come up with a single table that would cover most of the world's most important living languages. It was very inclusive. So you'd have your Japanese and your Chinese and your Korean and your, Shinafadas and things like that. There was major debate about whether or not Klingon should be included. So it was that extensive. In the end, I believe the Klingon was not included, but I'm not sure. We could look it up. But that was one of the issues. So you can imagine if you're arguing over Klingon, you have a fairly comprehensive character set at that stage. All of the real people have been catered for. So if you code a document using Unicode, then it should display on any browser that's capable of doing that. Now that's no mean feat. I mean, you know that would be quite a feat for the operating system to be able to display any language. But at least there's no confusion. No. So a character set then takes one or more bytes. So in ASCII, for example, uppercase A is 65. It's 0, 1, 0, 0, 0, 0, 0, 1. Yeah, 'cause that's 64 plus 1. And ASCII was a 7-bit code. There's 7 bits there, isn't there? Well, that's 8. Yeah. So ASCII can be represented with 7 bits or 8 bits. 1, 2, 4, 8, 16, 32, 64. Yeah. So generally, because bits come in blocks of 8, we usually don't bother with 7-bit ASCII that much. We use 8 bits for each character. But the issue that came up was that only half of the table was properly defined. And then country by country, people used the other half to do what they wanted. Now that wasn't a problem. If you had a French computer system and you had all your computers connected together in a company, that wasn't such a big deal, as long as they all agreed on what the mapping of bits to characters was. If you connected that system to other computer systems in the same country, well, again, that wasn't a problem as long as you all agreed on what the mapping of bits to characters was. But when your French system starts sending characters to Spain or to Germany, well, then you have a problem because there wasn't agreement between countries about what the other half of the ASCII table would look like. You sometimes see that even in a text message. If you get a text message from France, it can be a problem if there's accents or grabs in it. It actually causes problems for, there was something in the paper there a few months ago about Gael Skull and the giving out, because if they send text messages with fathers in them, because the e-father isn't part of the baseline ASCII, then the entire message has to be sent using a 2-byte code instead of a 1-byte code. And so it takes twice as many bytes to send the message. So they end up paying like twice as much if the message didn't have a single father in it. No, I think that's actually something wrong with the messaging services that they're using. I think they're not designed properly. But they were giving out like mad because they were paying, twice as much for every text message. So you can see how this thing can cause problems anyway. No. So we have then a character set called ISO 8859-1, and then that's basic. See, if you're only using English characters, you don't even notice the difference, because uppercase A was 65 in that, uppercase A is 65 in this one as well. But it does mean that the e-father, as we might call it, does actually have a properly specified value then. So this means then that if someone is writing in Irish or writing in French, I imagine it covers Spanish as well. All those languages, the funny characters, as we might call them, there's agreement on where they sit in the table. And that character set is fine because it's still only 1 byte. So it doesn't actually take a whole lot, it doesn't take any more space than we'd be using otherwise. Because even if we're only using 7-bit ASCII, because bits come in boxes of 8, we just use the 8 bits anyway usually. That's not a problem. Now Unicode then typically requires 2 bytes. Again, A would be uppercase 65 in that. They mapped the uppercase A so that it would have the same position in ASCII, in ISO 8859-1, and in Unicode. So there's no issue there. And the eFADA or eGrav, that's the acute actually, sorry, that's an acute E. That's still 233. But then there's other parts of the table in Unicode that wouldn't have been there in the other sets. And so this character here, which looks Hebrew to me. Does anybody read Hebrew? That looks to me like a Hebrew character anyway, so I don't know what it's called. But that has a value. So it means then you can have interoperability across the web for your pages, for your documents. So if your page is just in plain vanilla English and you don't even have any Sheena fathers in it, well, you might just go for bog standard ASCII. If you are having accents and gravs, but you're using basically the main Roman character-based European languages, so I mean, it would probably work for Polish also, but probably wouldn't work for like in Macedonia. I think they use the Cyrillic alphabet, and Greek. The Greek alphabet used in Greece and Cyprus. I don't know if that's part of ISO 8859. We could look it up. But then if you're going to be writing in Hebrew or Japanese or Korean and you've that in your document, well then you'd use Unicode. And then at least there'd be no confusion. You're nothing getting screwed up. So that's why when you're making a web page you sometimes have to put all this pointless gibberish at the start specifying what the character set is. But that's just to make that perfectly clear and explicit. So basically what happens then is you can have 1-bit codes or 1-byte codes or 2-byte codes. And so we can see the difference between those there. I'm supposed to dwell on that. Now, so like I was saying, the 7-bit ASCII goes back to ye olden days, and that's the lowest common denominator. So if you're just using plain ASCII, it's always going to be compatible with all the other sets. So if you're writing documents in English, you can be a bit lazy. You only need the default setting would be ASCII anyway. You know what I'm saying? I think I'm talking too much. It's not nearly as complex or elaborate as I'm suggesting. I'm just stalling for time. No. So, yeah. So ISO 8859-1 then you can use for English and for most European languages. So it would have E, gravs, the Nyas, the squiggle over the end, things like that. But there are plenty of languages not included in that character set then, and even some characters can be a bit off. You might not get your curly quotes and things. Okay. And so sometimes when you're using 8859-1, you have problems. In which case then you have to switch to to Unicode perhaps. So here we have some things from some funny languages, about which I know nothing. And this side is just basically showing you that the way they map they try to make it so that the character in the different character sets has a logical spot, in the bigger set. So that it's usually, if it's, say you have the 1 byte character set, those characters, if you put them in a 2 byte character set, the second byte is still the same, and they've just got sort of padding almost in the first byte. So that's just what that's showing there. It's not particularly illuminating. Blah blah blah. Yeah, okay. So I think I'm going to leave it there actually, guys.